Hello, everyone, and welcome to the Prequel podcast. I'm your host, Lyndon Brown, co-founder and CEO of Prequel, and I'm really excited to have Dan Slimmon on today's episode. If it's cool, Dan, I'll do a quick intro. I don't want to make you uncomfortable. Is that okay?
I love being introduced, please.
All right, awesome, awesome. Be careful what you wish for. So let me start off. Dan's always looking for trouble. But let me explain what that means. At companies like Hashicorp, Etsy, Clerk, he's been tasked with understanding where applications will fail, ideally before they fail, and getting them fixed. Since 2012, he's shared some of these lessons on a very impressive blog, I will say, blog.danslimmon.com, scientific incident response. Did I get that right?
Hmm.
And Dan's, unique perspective isn't just about preventing and fixing issues, but really about helping us rethink how we understand and manage this complex human-centric systems. Um, I love Dan's writing because I always feel like he brings a fresh perspective. It could be an analogy, it could be a framing that I haven't heard anyone else approach it in that way. So really excited to sit down with Dan. I appreciate you carving out time, Dan.
I'm really excited to be here too. I've been following Prequel since we met at a New York platform engineering meetup, and your talk was just I heard it and I was like, oh damn, this is exactly what the industry needs. We got all these observability companies fighting for scraps in the intertidal zone, and somebody's finally doing, problem detection rather than problem, observability. So hats off. Can't wait to, this is gonna be a great conversation.
Yeah, I appreciate that, Dan. And since you mentioned the meetup, if I recall, I think I actually had to follow you on stage, which is not a very enviable position to be in.
Yeah.
But hopefully,
And I think I had my arm in a sling at that time, so
yeah,
I
yeah,
had
yeah,
the
yeah.
extra sympathy.
Yeah, exactly,
Yeah,
exactly, exactly.
you did pretty
Um,
good.
Yep, thank you, thank you. But rewinding the clock a little bit, I mean, I kind of talked about your unconventional thinking, and I guess the theory I have is that maybe your unconventional background contributed to that. Now, to the extent there is a conventional background for infrastructure engineering, et cetera. But maybe let's dive into a little bit of that. From my understanding is you got started in math and physics, kind of like that domain, and then made the jump over to infrastructure engineering. Yeah, maybe tell us about that and how it
Yeah.
impacted your approach.
Sure. I mean, I think it did. So I went to a liberal arts college. I went to Wesleyan University, and so that's part of it, right? So it's not like I went to some program that was like all math, all physics, all the time. I learned how to write essays and stuff and
Yeah.
do research. But like, yeah, I majored in physics and math, uh, and I uh, I ended up finding out that I wasn't really cut out to be a physicist. But the idea of like taking fundamental, a fundamental understanding of the field that is complex and breaking down the parts of it that I don't understand until they either fit one of the rules I know or don't fit one of the rules I know. That sort of scientific iterative approach has stayed with me. I still use a lot of the like principles that I used in physics and math, especially linear algebra and statistics, just as frameworks for doing my job as an SRE. But I found out after administrating an open Mosix cluster in the physics research that I was doing that I'm way better at Linux than I am at physics. So here I am.
Well, that's awesome. And maybe two things jump out at me. First, linear algebra is obviously all the rage now with LLMs and AI, et cetera. So hopefully you still have some of that. But the second piece is if you think about like physics and like discoveries, right? Like, I guess the way to think about it is like the universe and the world, they have these secrets, right? That you're trying to figure out. And is there an analogy there with systems?
Uh, Absolutely. Well, although, and when it comes to investigating what's systems behavior, the explanations for like a software systems behavior, the analogy I tend to go most often to is medicine.
Hmm.
Uh, so in medicine, like in clinical medicine, you have a patient who is an extremely complex system with where there are, you know, an infinite number of processes going on inside the patient that you don't have access to see. And even if you could
Mhm.
see all of them, you couldn't put them together in your head in a model. So you use pinpointed tests that you have. You know, I can test blood levels for this chemical compound, or I can, you know, do an X-ray on this part of the body to see
Yeah.
what's going on in there. You know, you have a limited set of tests that you can decide and questions that you can decide to ask, and a limited amount of time to ask them in before the patient dies. So it's I use that analogy a lot as the scientific basis for how I do incident response and investigation and problem diagnosis in software. It's pretty. I don't know. My wife's a vet, and so far she hasn't told me stop saying that it's not correct. So I find it to
Yeah.
be a pretty useful analogy.
Yeah, no, that's awesome. And I think the aspect of, I'm sure you remember the TV show House. I do
Mhm.
often think of incident response as the TV show House, except for with patients, you have the added signal, the subjectivity of a patient describing their symptoms or their pain level, right? On a scale of 1 to 10, what's your pain? 7? What does that, kind of mean? But hopefully it's at least directionally correct. Going back
Yeah,
to the physics side of the house, and one thing that's very evident in your writing is that you seem to have fallen in love with kind of queuing theory at some point, and have done a lot of you're claiming that, which is great, and have seem to have done a lot of research there. And obviously, a lot of statistics and math, especially in the early 1900s, was really being laid in support of early telephony systems, right? So you have various innovations coming there just to figure out, okay, how do we deal with like this new technology and the demands that are being placed on it? So maybe dive a little bit into queuing theory, Dan, and how you've approached it.
sure. I know just enough queuing theory to be dangerous,
Okay.
and I read a book on it. I did some of the exercises in a textbook on it, and then from then on, I just think about it all the time. But I never like became a queuing theorist, right?
Mhm.
Uh,
Yeah.
but it what the ways that it helps me most are, well, first of all, Little's law. Uh, I use Little's law at least monthly, where I say like, well, any queuing system, no matter what the behavior is of how you're pulling things off the queue or what's going on in the processes or how many queues there are or how they're hooked up to each other, it's always true, that, almost always true, that the number of jobs waiting in the number of jobs in the system in flight on average is going to be equal to the rate at which jobs are arriving times the amount of time that they're waiting in the system, the amount of time that they're spending in the system. And using Little's law, queues pop up all over the place in software systems, and using Little's law, you can immediately rule out whole classes of things that could explain the phenomena that you're looking at. Because if those things were true, then Little's law would be violated, and Little's law can't be violated on average for long periods of time at all. So that's very, very, very valuable because in a discussion about, well, why is this queue forming in this way in the database? And if somebody throws out three ideas, I can often knock down two of the ideas right off the bat and get to a solution faster. More broadly, what queuing theory taught me is that queues are not just widgets that you stick in your software. You're like, oh, I will have a queue here, and then we'll have a queue over here. They're they're naturally occurring phenomena. A queue emerges whenever you have more people who want to use a resource than the resource can service at the same time. Uh, and so that allows me to eliminate. So like if there's a queue forming in the database, where way down upstream of everything else that's going on in your stack, uh, that allows me to eliminate any sort of potential solution to that involves eliminating that queue, because you can't. All you can do is move it around, uh, or uh, or make people stop wanting to use the resource that you are that's for where the queue is forming. Uh, and so like I don't even worry anymore about, oh, well, maybe we need to queue these different. I used to be like, oh, maybe we need to queue these differently inside the application, queue the request differently inside the application, and then, that'll smooth things out and I won't have to as much. No, you have two options and that's it. And having that like mathematical certainty about what's possible and not possible via queuing theory has made so many of my decisions so much easier.
Yeah, that's awesome. And I think that perspective and even those mental models are so important. So we don't look at every incident or every behavior as a kind of unique snowflake and look, okay, like, what's true? Like, what are the laws here that like have to be true and things like
Right.
that. So maybe diving into your experience, let's talk a little bit about Hashicorp. Obviously, everyone knows Hashicorp. Everyone has likely touched one or more of the projects or the products themselves. Terraform, Nomad, Console, Vault. And My understanding was that your mission there was to basically identify problems before they became big headaches for customers or for the internal team. So can you tell me a little bit more about this role and what made you the right person to take it on?
Sure. I it's kind of just my natural mode of operation that I will get distracted by something weird in a graph or in a log or in a trace or whatever, and want to go down that rabbit hole. And this makes me ineffective at long-term software development projects in general, uh, but it makes me very effective at finding uh, problems that are getting worse or are going to get worse and connecting together the various people who have the parts of the mental model needed to understand that issue. Having developed this intuition over time by going down thousands of these rabbit holes, I can usually at least come up with a potential way that this spike in a graph could could mean an outage further down the road if we don't fix it. I can explain why there's risk there, and then I have had a lot of practice at uh, learning just enough about the various pieces of the system to be able to leverage other people's mental models of things they know better than I do to expose like what's the underlying mismatched assumption that has allowed this situation to emerge. And then once I'm done with that, once I've you know laid bare the mismatched assumption between groups of people, they will usually just say to
Mhm.
themselves, "Oh, we should fix this. I can think of
Mhm.
how to fix this," and then I can step back and go down a different rabbit hole.
Yeah. And the timing when you were there, I know largely a lot of maybe on-prem type solutions and then kind of a Terraform cloud really being kind of the first kind of major cloud offering. So I imagine that brought a whole new set of surprises and potential failure modes. Can you dive a little bit more into that and talk about some of the kind of key wins you had looking for trouble at HashiCorp?
Yes, so HashiCorp was a great place for to start and make a bunch of impact doing this thing I'm talking about, which I call looking for trouble, uh, which because we had been shipping, so HashiCorp had been in the business of shipping software binaries on a release schedule that were then downloaded by the user and used in their environment.
Mhm.
Uh, Terraform Cloud was not their first software as a service offering, but it was the first that really took off. And so it was a good environment for me because it was a lot of very experienced engineers who knew their software, who knew their code base inside and out, but had little to no experience uh, operating a system that needed to respond to arbitrary customer traffic from the internet. Uh, so that I was able to like because there was these were so experienced and knowledgeable developers, I was able to get a lot of traction. Uh, you know, Getting their eyes on something that was happening and having them be like, "Huh, that's weird."
Mhm. Mhm.
Uh, and as soon as I hear somebody say that, I know that I can like move on to something else until they get back because like I've become very good at nerd sniping people. HashiCorp was a very target rich environment for nerd sniping.
Yeah, yeah. And prior to HashiCorp, you were at Etsy, right? Different business model. There's quote unquote enterprise software, and then there's e-commerce. So like, how are the demands different for what you do at Etsy?
So at Etsy, I was on the observability team, which meant I was responsible for Elasticsearch, Logstash, Kibana, Graphite, that
Yeah.
sort of thing. My team was, it was a 5-person team, and the the I would we there Etsy was different because it had a very collaborative and well structured incident response process. Everybody knew they could be called into an incident. They knew what to do if there was an incident. There was a spot on the calendar every week for the incident postmortem that you could fill. And if there was no incident to do a postmortem on, great, you get your time back. So I was just helping a lot in investigating, hey, why did logs stop coming through this system?
Yeah.
One of these 200 config files in this log in the log retrieval config is messed up, but we can't tell which one. And I would come in and be like, well, let's binary search it.
Mhm.
Let's turn off half of them and then see, and then we'll turn off the other half and then, or turn off half of those, right? And then we'll eventually be like, pretty quickly be like, oh, this is the config that's messed up. So I learned, a lot of my little like, random on the fly seat of our pants techniques for investigating and getting like buy-in on a given explanation of an outage. I learned at Etsy largely because it had such that like incident forward, investigation forward culture.
Yeah, and Dan, and do you attribute that to the nature of the business itself being, fundamentally like a quote unquote
Uh,
online business, right?
I mean, uh, SaaS is always the the place where if you're running SaaS, uh, then then you have customers who are using your thing, and customers are like inherently unpredictable about what they're going to do, how they're going to use the software. So at Etsy, like, well, I guess at Etsy uh, it was interesting, especially interesting because we had a two like it was a bi-directional market that we had there,
Yeah.
and so we have to be concerned about like not just what the buyers are going to do on mass or individually, and not just what the sellers are going to do on mass or individually, but what happens when different patterns of usage collide in the middle, and that we didn't think of when we were designing this, because this socio-technical system of users and buyers and developers all interacting with each other is too complex to predict everything it's going to do. So I think that's probably why Etsy developed such a strong culture of look at what's happening and respond to what's happening, rather than trying to like plan everything from the outset and know exactly how the software is going to behave in production, which is where at HashiCorp, because they were shipping binaries on a release schedule,
Mhm.
HashiCorp, I had to help move them in more in the direction of look at what's going on. Etsy was
Yeah.
already there.
Got it. Yeah, and I imagine also that where uptime literally means money, whether transactions not flowing, etc., is a little bit different than software where you're maybe under an annual contract, right? And revenue isn't as much at risk there, but who knows?
Yeah, I mean, tell
Um,
that to the C try telling that to a CTO, but you're
yeah,
right.
yeah, 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 yeah. So yeah, so maybe talk about scale. I mean, because Etsy, large scale. You mentioned observability team, and I think you wrote about it. Lots of data, right? Like terabytes of data per day in observability data. So what were some of the tools and tricks that you leveraged to help the team get insights from that data?
Uh, at Etsy, I was very lucky that, but because of the culture that I described, that most of that as an observability as a member of an observability team, my job was to field the requests that came from the largely to field the requests that came from developers because they already knew they knew what data they wanted, they knew what questions they were going to ask about it. And so they were just like, well, we want to send a terabyte of log data into this Elasticsearch cluster that you have. And I would say, yes, sir. Let me figure out how we're
Mhm.
going to do that. Um, but at throughout my career, there's been there've been situations where like the the data is all there. Like the data is often all there because everybody's like, well, why don't we just log everything? Why don't we just put everything in? You know, we got this Datadog file, we'll throw it all in there. But I've had opportunities to help people learn sort of this scientific approach to figuring out what question to ask about the data. You know, you could have an infinite amount of data,
Mhm.
uh, and at SE it often felt like we did. But if you don't have a question, if you don't have a model in your head of how the system's supposed to be working, then you can't figure out what question to ask of all this data, and so all of this infinite data is useless to you. So I've made a habit of guiding people toward this model first approach to
Mhm.
observability that I think is helpful, is very helpful for people.
Yeah, that makes sense. And I guess let's go back further in the timeline here. And I'll think of this as perhaps the definitely pre-Kubernetes world, perhaps pre-cloud world, you'll tell me. But you were, I know, at Exosite, and then you also worked at a political marketing. There, I still got the hoodie. That's nice. And
These hoodies are so good. I still wear it like weekly. I got this hoodie like 10 years ago, and
yeah.
it's the best hoodie I've ever gotten as swag by far. Anyway, go on.
Okay. All right. Yeah. Offline, I'm gonna get the brand from you. They're
Yeah, I'll
not
tell you.
sponsoring the pod, so I
Yeah,
don't
no,
want
fuck them.
to. So let's talk about Exosite and working on that political marketing campaign.
Yeah,
I know you were sending out hundreds of millions of messages per day at the political platform. I
yeah.
feel like all of those are making it to my inbox. I'm not sure, but so thank you, I guess. But tell me a bit more about that experience, and how was reliability perhaps thought about differently, right? In the world, kind of like pre-Kubernetes, pre a number of other supporting cloud services, et cetera.
Yeah, yeah. It was it was a pretty different world. I When I got that job, um, I was straight out of college. I had just been doing that open Mosaic cluster that we talked about for
Yeah.
the this physics department, and we had just the company, it was Blue State Digital. We had They had just gotten Barack Obama as a client,
Hmm.
and uh, they were thinking, "Oh, this will be great. We'll be able to. This will be, our first opportunity to do a presidential primary, which we've never had that kind of scale before. And obviously, Hillary Clinton's going to beat Obama in the primary, but it'll at least get our name out there, and everybody will be, maybe next time." We'll catch a bigger client, and of course that's not how it turned out. So our scale just went, and Obama was an incredible fundraiser.
Hmm.
Uh, the Obama campaign was like putting the URL that went to our servers directly on like donate.barackobama.com. They put it on a big at the DNC. It was on this huge billboard, and the camera would cut to every few minutes. So it felt like we were building the ship while we were under fire by enemy cannons. And so I learned, I was putting in very long weeks there, and I learned a lot, including don't eat lunch at your desk, and don't put in 14-hour weeks anymore, or 14-hour days anymore. But but it was a lot of back then. It was the late 2000s. So it was physical servers in a data center that I would have to go to sometimes. And you would SSH to the servers. You had scripts to SSH to a bunch of servers, and they were all heterogeneous servers because you buy the servers at different times and you put them in the rack, and then you change what they
Yep.
do over time. And so you have to remember all these little quirks about, oh, okay, Obama has these servers and the DCCC has these servers, and they have slightly different characteristics and the traffic's totally different. So one of the things that's nice about the cloud now is you can a lot of these workloads are just like you can put them on uniform stuff, and because we treat our servers as as like what cattle, not pets, they say, then
Yeah.
if you want to change any of the performance characteristics of your underlying hardware, you just make new hardware and point the workload over there. And in the late 2000s, that was not possible, and I spent a lot of long days in a hot, loud data center, not being able to eat anything because you're not allowed to eat in the server room.
Yeah.
I don't miss it, but I learned a lot.
Yeah, and I imagine that's why you have the hoodie because it was probably a little cold in in the data center
Oh
room
yeah. Well, this
as
is from
well.
Exosite. By Exosite, we were already in the cloud. We were using
Nice, nice, nice.
Linode.
Gotcha, gotcha.
Yeah, but it was Minnesota. I was in Minnesota, so that's why they gave everybody
Got it,
hoodies.
got it. No, that makes sense. And yeah, I mean, look, a lot of things have changed since then. Do you see what? Do you see any downside to the shift?
Um, I mean, uh, some of the cloud. So some of the downside for me, at least, is that in the cloud, there comes with the cloud, there comes this expectation that there's going to be weird stuff going on with the kernel and with the network and with the IO because you're on shared
Hmm.
infrastructure. And so there's just weird stuff going on all the time that you should not bother trying to explain because it's part of being in the cloud. Uh, and that's fine. There's definitely always stuff that you should not bother trying to explain, but I find the cloud has a higher noise floor for, what can be considered worth digging into and what's not worth digging into, which means that you can miss problems in your software and your stack for longer because they blend in with the other noise of things that are not your problem, and so there's maybe a higher probability that because you eventually stop looking at the stuff that's
Hmm.
below the noise floor, there's a higher probability that some of those issues are going to suddenly recombine with some other issue and explode into an outage before you get a chance to understand what's going on than there was with, a dedicated hardware in a data center that you can physically touch. So if there's any downside, is that. But I would not trade. I would not trade sitting at my desk all day, dealing with cloud infrastructure that's in Ohio for going back to the data center. I would never trade that.
Yeah.
This is better, much better for me personally.
Yep, yep. And there's a whole separate cost debate that's taking place. I'll leave that for another
Yeah, right,
podcast. See how the
right.
CFOs deal with that.
They're like
Um,
they're like the Netflix. They're now like how, oh, everybody come over here to Netflix and HBO Max or whatever, and
yeah,
it'll be better, and it's better for a while, and then they're like, ooh, everybody uses us now. We can make everybody watch ads and pay
yeah,
twice as much
exactly.
per month for everything.
Yeah,
Yeah,
exactly. So the current state of play in that world is probably each person having five streaming apps, each with commercials now,
yeah.
paying more than you probably were paying per cable originally. But we'll have to address that as well. But maybe let's talk about the misconceptions, right? So like, obviously a lot of people nod their heads to being more reliable, wanting to be more reliable. Sounds good, right? When the rubber meets the road, different trade-offs get made. But what's something that you think either practitioners or leaders get wrong when they think about reliability?
Uh, I my big thing lately about this has been I've been reading a lot of philosophy of repair and maintenance. In
Nice.
particular, I recommend this there's this one very accessible and good paper called uh, Rethinking Repair,
Mm,
by I think Stephen Jackson. Don't quote me on that, but it's
okay.
very good. It's about 20 pages. Anyway, what this led me to understand, and a bunch of other papers I read as a result, is uh, there's this misconception that if a system is built right, it will work right. Or the contrapositive of that is that if the system's not working right, then you didn't build it right. Uh, and this lends itself to a lot of problems in the reliability space. Uh, where people think that if anything goes wrong, oh, it's a bug. We didn't include the right requirements, or it's a bug in the software, or we have failed in some way to build it right, uh, because it's now, hitting CPU peaks when this traffic pattern comes in or whatever. And I think of it more as, uh, you have a given system that behaves in some way when exposed to different stimuli or inputs, different sets of customer traffic, and some of the ways it behaves are going to be pathological, in response to the workload that you're exposing the system to. So if you get a spike of traffic that causes, that causes your load balancer to queue a bunch of requests in a pathological way and induce a bunch of latency, that's not necessarily a bug or a problem with the system that you created. It's because if you had a different set of traffic, if you had ended up with a different set of customers doing different set of behaviors
Mm.
for a different set of purposes, the way your business develops, you would never have encountered that problem, and it would have been ridiculous to include it as a requirement in initially designing the system, because it would have been a waste of time. It would be a waste of time to fix it, even
Mm.
if you did realize it was going to happen, because it's not a thing that's actually happening to. That's not a situation that's actually happening to your software, right? So I don't see it as the system is either broken or working, and if it's broken, you did it wrong. I see it as you have a complex system that's out in the world, like a body, like a human body, and sometimes it's going to encounter situations that cause it to behave pathologically, and that's natural. That's a part of operating a system in the real world. It's not a it's there's a great quote from one of these papers I read cited in the Rethinking Repair, that's, to invent the train is to invent
Mm.
the train crash.
Mhm.
You know, uh, failure is a natural part. Like, failure at different scales constantly in all sorts of different forms is a natural consequence of operating a complex system in the real world.
Yeah, and Dan, I'm glad you raised that quote. I've actually heard a similar version of the quote, but it was the ship and the shipwreck. So it seems like there's an apt version for every level or timeline of innovation. But that makes a lot of sense. And yeah, I think you don't as you think about the specific usage patterns, like users are inherently unpredictable. Like they want to solve their problem, and they will use your software or your application or your platform however like it best helps them solve that problem. And you often don't know that, right? You often don't know the different twists and turns they're gonna do. Maybe they'll upload a large CSV file that you never anticipated kind of being uploaded. Those kind of things definitely happen once you're out
we
there.
we had people, I don't know if I'm not allowed to say this. We had people at HashiCorp, customers, who were uploading like 12 jar files all together into their Terraform state file, which we then had to store their 12 jar files in our database. The API doesn't say you can't. So
Hmm.
now it's our problem to store this gigantic file, which takes 100 times longer. Means those operations against that state file are going to take 100 times longer than everybody else's requests, and that's just part of the game.
Yeah. And you mentioned the volume of data, right? So it sounds like given this, the key thing is being able to have a very fast, kind of feedback loop, right? Being able to, hey, we can't anticipate everything, but like let's quickly be able to know that it's happening and being able to take action. And you also mentioned that the noise floor is a lot higher now, right? So it's like stuff is always kind of, not ready, failing, but a new container will pop up, etc. So teams are definitely tasked with, okay, how do we kind of cut through this noise? I'll say this. I think AI is all the rage in every industry right now, but AI and engineering, IT, software has had a unique, relationship, right? Where I think it was 2015, I want to say, Gartner first had a hype cycle where they put AI ops, on the quote unquote proverbial map. And now we're sitting at about a decade later, and let's just say the hype cycle has played out in terms of, inflated expectations, disillusionment, and the rest of the story to be written. So where do you stand in terms of thinking about AI, anomaly detection, variety of different tools in the sport of root cause analysis?
I will say I've been extremely underwhelmed by machine
Mm.
learning anomaly detection algorithms ever since were introduced. And so far with the AI root cause analysis, I've had a few of those products demoed to me, and I, more I wish them the best of luck, but they're definitely not anywhere useful to me yet. I think that's because uh, the an anomaly is only an anomaly if it is surprising to you. And the machine learning
Hmm.
algorithm doesn't have access to my mental model and can't determine what's going to be surprising or interesting to me. It's that's all in here. It doesn't, for the people on listening to the podcast, I'm pointing at my head. That's all in here. Like it doesn't know. So it's constantly showing you like things at the wrong level of abstraction to be meaningful, or correlations between numbers that are, yes, there's a correlation there, but what do I care? Or spikes in some metric that that immediately recovered and has no impact on the reliability of the product. Uh, to me, uh, resilience is how we achieve reliability, and resilience is always powered by a feedback loop. The behavior of the system in production uh, gets observed and processed by us into a better understanding, or a more nuanced understanding of how the system behaves, and then we translate that understanding back into actions that affect how the system behaves. And there's this feedback loop between the operators and owners and the system's behavior itself. I see my job as a reliability person is to remove as many barriers as I can from that feedback loop, so that like system owners and developers find out about surprising phenomena early, so they can update their understanding in time before those surprising phenomena uh, combine with each other to cause outages. These things grow at different rates. Some of the surprises will grow very slowly into an outage. Some of them will grow very quickly into an outage before we have time to fix them. Some of them will never emerge as
Hmm.
maybe even most of them will never emerge as an outage.
Hmm.
But what we can say with certainty is that every time you do have an outage, you do the postmortem and you look back at the signs of what you look back at the what caused that outage, and you're gonna find a handful of the surprising things that you didn't know about before the outage, and that you could have seen if you knew what to look for,
Yep.
right? So that gives me confidence that if you do just go out and start looking for things, some of the things you're going to find are things that would later have turned into an outage, and it's better to pay that cost of maybe going down some rabbit holes you didn't need to go down, because it gets you some of the outages. You get to prevent some of the outages that you otherwise would have had.
Yeah, no, I think that's the stage well then of the kind of current dilemma, right, that most engineering teams deal with. You kind of talk about problems being normal, like they will occur, and not being able to know which will slowly, quickly, or never become incidents. You talk about the noise floor being raised, so maybe there's always going to be something weird in the graph. So if you take a room of, let's say, 20 engineers, right, and everyone has that screen up next to their IDE and they're looking at production and they're seeing what's going up and going down, I posit that a percentage will go chase the graph, and another percentage will the larger percentage will kind of say, hey, let me focus on these sprint goals, etc. So if I was building out a team and I'm like, okay, like I can't rely on just the happenstance, and I want to kind of structurally do this, right? So, okay, let's make the investment, and we can talk about what that looks like. But how do I actually go ahead and like stand up, a team or a process around looking for trouble in my applications? Like, how have you done in the past?
So it's definitely true that the incentives, I think of it in terms of incentives, but there's also a matter of like personal curiosity involved too. But that for some set of reasons, the probably the majority of software people who are working on the software system are not gonna go down are not gonna go like looking for trouble or go down these rabbit holes unless you make them. Uh,
Mhm.
I tend not to want to force people to do things. I
Yep.
try to, so I have a lot of different strategies, but they tend to focus on leveraging the existing curiosity in the org. I can't teach people to be curious, but I can identify people who are asking good
Mm.
questions and be like,
Yep.
oh, I need to have a, like let's get her in the next looking for trouble session because she's clearly interested in going down understanding things just by virtue of her curiosity. So I find the people who I think are going to contribute best, and I invite them to participate with me in this process. And I try to build a sort of a robust network of people who are regularly contributing a certain amount of time per week to this uh, to this endeavor. And the flip side of it is when there emerges when we fix things, uh, I I I try to like make sure that stakeholders in the organization know what we fixed and why it was risky. So I push that out to people, uh, and I've been able to survive in various organizations through just like a combination of intuition and personal excitement and charisma
Mhm.
to like get people involved and keep a movement going. Once the movement starts rolling, then stakeholders tend to see, oh, well, they found like I see why I they fixed this thing. They found I don't know a bunch of jobs that built up in the queue and eventually cleared out that if it had been twice as many jobs, then we would have hit a limit and we would have had an outage. So they're solving these problems before they become. That's what people, I think, higher level stakeholders in the org want to have happen, but they don't know how to make it. They don't know how to make it happen through bureaucratic top
Yeah.
down processes. And I try to make it happen for them through non bureaucratic network based type human curiosity focused ways, and it works pretty well as long as you have the personal energy and interest to make it happen.
Yeah. And if you think about the timeline, I think early on, whether it's logging or telemetry or tracing, metrics, etc., I feel like many organizations were starved for that. Where we sit now in 2025, is it fair to say that we maybe have a hyper visibility problem, right? Where, and then, it's just like not the absence of data that's the problem, but it's almost the presence, in some ways of too much data, or how do you think about that?
I there's a kernel of truth to that,
Mhm.
um, but and I think that it's certainly the case that at least for logs, for instance, almost in any organization, 99.9999% of the logs are you're never going to see. And so that feels like waste. That can feel like waste to people, and it
Yeah.
can feel like noise. But I don't see it that way. I think that I've been able, so this through this, like I do this thing called clinical troubleshooting, which is this like uh forklift of medical differential diagnosis onto the software ops field, where you list the symptoms that you're aware of, like that describe the problem you're interested in. You have a finite set of symptoms that describe the problem you're interested in. Then you come up with a hypothesis some set of hypotheses that explains those symptoms, and you take actions to falsify hypotheses until you have one that you can't falsify, and then you go based on that. May not always be
Mhm.
totally correct, but it's useful. It's a useful theory. Uh, if you use this pattern or a pattern like it, then suddenly the data is not overwhelming. The huge amount of data is not overwhelming anymore, because you're you're not just looking for data that proves what you think already. You may not even be sure what you think already.
Mhm.
You're
Mhm.
looking
Mhm.
for data that disproves,
Mhm.
uh, particular
Mhm.
propositions, and
Yep.
that you can usually find. You can ask a if you have a ton of data, you can ask a very targeted question that will give you a yes or no. You may have to make a spreadsheet, but like you could ask a particular question that will at least tell you you don't have to worry about this anymore because it's definitely wrong. And if you do that, like you could have an infinite amount of data. The model informs what data you need to look at specifically to answer a question, and it removes that problem, at least for me.
Yeah, no, that makes sense. But I think what you're describing is that for most organizations, right, to be able to achieve this, they kind of need a Dan. They kind of need willful participants, around that. And then they need the business aligned with the trade-off, right? The time trade-off, the attention trade-off, that's associated with that. And as you mentioned, Prequel, all these things are ultimately what led us to start Prequel. And one of our observations was that so many times at the end of, let's say, an incident, right? You're briefing the leadership and you're explaining what caused the incident, and then the CTO or whoever might say, okay, like why weren't we looking for that in the first place, right? And everything seems so obvious, like once you kind of know that that's what caused it. But to the left of that, like how do you possibly develop all these hypotheses at scale, disprove things, and then also like maintain those models. So what we were motivated to do, and one of our insights was that while internal knowledge, obviously there's knowledge, and well, internal knowledge of possible problems is there and it's growing. The larger set or knowledge base of potential problems exist outside of the organization. So when we started Prequel as a problem detection platform, we recognized that really the a lot of unlocked knowledge just existed in the community, right? Some of this might be documented on a GitHub issue. Some of this might be sitting in your head, but no one has perhaps given you the tools, the opportunity to codify that knowledge so that whether it's your organization or if you want to share it more broadly, you're able to help teams proactively test those hypotheses, look for problems. The second piece, as it relates to dependencies, all modern platforms are using a crap ton of services that it's difficult enough to maintain knowledge and expertise across the board in your homegrown software. But when you think about all the dependencies, the Kafkas, the RabbitMQs, Kubernetes itself, Nginx, you name it, right? We find that teams have a wide but necessarily kind of shallow knowledge base in terms of all the knobs and dials and bells and whistles that go along there. So if it's cool, I would love to maybe bring up the product, show you a quick use case
Yeah,
on how
I
we're
can't wait.
helping teams do this.
Yeah, let's do it.
Awesome. So you should be seeing my screen now. And basically, I think the core thing to think about in terms of observability versus problem detection is that we definitely acknowledge and recognize being able to apply experience and skill sets to just raw data is valuable. But what we also realize is that not tapping into existing knowledge is a missed and lost opportunity. So what you see here is part of the product, which enables you to actually tap into community knowledge. And in this case, I loaded up a couple of rules. So you see a couple dozen rules represented here. And each of these rules are specific problems that, again, in a given environment may exist, may not exist, may cause an issue now, later, etc. But the key thing here is being able to look and see, is this happening in your environment? So you see a number of things represented here. I'll pick on one example here, which is a salary worker, job processing platform, and being able to actually recognize out of the box that there are known issues. There are specific ways to detect and look for these issues, and really moving detection from something you do after an investigation to something you can do proactively in concert with the just human curiosity being applied to the system. So what it looks like when one of these detections does fire is you get notified. And then I think the interesting part about here is now you're able to actually apply that internal expertise to say, okay, is this something to worry about now, later, et cetera. And part of what contributes to that is the context that's being provided as well. Well, being able to understand if there's an uptick in this particular issue, uh, having knowledge and looking at a service graph to understand the dependency between this service and other services, and understanding also the context of request, right? Are we seeing this in an environment where we expect this usage pattern to continue? Is it somewhat anomalous so that it can be prioritized in a true kind of problem management function? So what we view and we leverage problem detection as is really enabling more automation, automation for things you don't know to look for, automation for things you may internally be doing, but doing in a very manual way, and teeing up these detections so that internal problem hunters, incident responders, engineers can actually have the information to prioritize what needs to be fixed now and what can be fixed at a later date as well.
It's an extremely cool product. I think this is going to be a valuable source of signal for people like me who you know maybe don't know what they're looking for when they get up in the morning. There's a lot of people who have hooked up their system already using these components that I use and have found problems with them, the things that were problems for them in their infrastructure that I don't know about yet. So I can't wait to see what happens as this develops. The 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 task of the operator of this prequel product then I mean this is still part of the task of any operator, but so this is going to give this person signal or about symptoms of potential problems, but everybody's system is hooked up has like
Mhm.
different components hooked up in different ways and different components serving different functions. And so to one person, celery worker exiting prematurely might be oh no, I didn't know about this. This is our production thing. And if the celery worker exits prematurely, it's going to cause all kinds of problems as it gets worse. And to another person, it might be like, I don't know, is this part of our CI? Like if we just retry it, if the worker exits prematurely and it restarts up back up and it doesn't matter to me. And there's a whole array of
Yep.
possible interpretations in between, so that the task of the operator is going to be to layer the meaning on top of what signal they're getting from this, and then express that meaning in a way in like to the tool
Yep.
so that they can actually triage the issues appropriately. But
Exactly.
it's going to be a lot easier to do that with a tool than it is without one. So I applaud the effort.
Exactly. Yeah, and that's exactly how our customers leverage us in those capacities, et cetera. So I'll meet pause really quickly and see if we have any questions from the audience. I think we might have had one come through. Awesome. All right. I hope it's cool with me saying your name. Martin poses a question here. Says, how do you go about introducing and building inertia around incident DDX when teammates don't have the same cultural canon?
Yeah,
So
maybe people haven't watched House MD or The Pit. or any
Yeah,
other
yeah, yeah.
medical drama show.
Yeah.
By the way, have you seen The Pit? It's so good.
Okay.
It's my wife's a vet. And she watches it and she's like listening intensely for mistakes in the medical jargon that they're using or like things that don't make sense. And it's very very
Mm,
accurate medical stuff, but it's like also great drama. Highly recommend. It's HBO, I think. I think it's on HBO.
yeah, HBO.
Anyway, anyway, uh, so it's pretty I think differential. So if you don't call it differential, as soon as you start calling it differential diagnosis, then people are like, "Ooh, differential diagnosis, that's fancy."
Mhm.
But it's pretty intuitive process, and most people already kind of know how to do it, but they don't do it. They do it inside their own head, and they do it informally, or they think they're doing it, but they're not really doing it. So you can draw on people's intuitions about uh, how troubleshooting works, but you write it down in a structured form, and you emphasize the importance of collaboration in the process. So instead of having the process go on in your own head, it's going on, in a way where everybody can look at the symptoms, look at the hypotheses, look at the actions to be taken, and go around in that loop together. I think you don't really even need to know that that like the framework comes from a medical background to do it effectively. Once a team has gone through this process formally a few times, they tend to just get it because it's pretty intuitive for them. And then you don't even have to do it. A large part of the time, you don't even have to do it formally anymore after you've done it a few times because people are starting to think in that. You only really have to bring out the formal differential diagnosis when the problem is complex enough and requires so many people involved to reason about that you need a formalism to get everybody on the same page. The 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 intuitive process of symptoms, hypotheses, actions is pretty sufficient for most cases, and it keeps people on page very effectively.
Awesome. Thanks, Dan. I think we're up at time, so we won't be able to answer any more questions live, but we will definitely follow up and appreciate everyone attending. Dan, it was awesome getting to to tap your brain. And earlier you mentioned the gap that can't be filled without having a look inside your brain. So maybe we'll have to do a Neuralink on the next one of these and see what's really going on. See what's really
Oh,
going on
great.
in
I,
there.
I can't wait to feel what that feels like.
Yeah, well, yeah, that should make for some good content. But ultimately, what we're about is there's a lot of hype around, maybe replacing SREs, replacing platform engineers, et cetera. And we agree with you, Dan. Like we think that no, like what you actually need is tooling that empowers and helps with automation and enables right all of us to really focus on our unique contributions to the org, which is taking that context, taking the business context, the platform context, understanding the users, working with internal development teams. You mentioned a lot of soft skills that have to be applied, right? Even in the question you just answered, there's a lot of soft skills that have to be applied to basically work and get teams to collaborate to move some of these the boulders here. And that's all stuff that gives me hope and promise for the future, supported by additional automation. So,
Yeah, I we're you and I are very much on the same page about this stuff, Lyndon, and I had a pleasure talking to you. I can't wait till you invite me on again. Humans, you can't have resilience without humans. Resilience comes from the humans. Everything else is just tooling.
totally agree. All right, Dan. Until next time. See everybody. Talk soon.
Thank you.